starting group number 17, or in old notation main group 7. It's fluorine, chlorine, bromine, and iodine. All of them have electron configuration ns2 and p5. One electron less from the closed shell of noble gases, neon, argon, krypton, and xenon. Size of this atom dramatically increases from fluorine to chlorine to much larger bromine, even larger iodine. Same is true for negative ions: fluoride, chloride, bromide, and very large iodide. First, ionization energy drops down from fluorine to iodine. At room temperature, fluorine and chlorine are gases, boiling point below zero. Bromine is liquid, and iodine is solid. Fluorine is most electronegative element in periodic system with electronegativity of 4. Chlorine is close to it with 3.5, 3.2. Bromine is still very electronegative, 3.0. Iodine is slightly less, 2.6. Fluorine is almost colorless gas. Liquid chlorine has barely visible yellowish hue. Bromine is bright red-orange, and iodine is almost black solid, but gaseous iodine is purple, very characteristic color. It is impossible to oxidize fluorine, so oxidation number of fluorine is always -1 in its compounds, or 0 if you have elemental. Chlorine, bromine, and iodine may have any oxidation number from -1, 0 to positive +7, or anything in between. Elemental fluorine is very strong oxidizer with redox potential 2.89, one of the largest known. Chlorine gas is also strong oxidizer. Bromine and iodine are oxidizing agents but much weaker. So oxidizing power of the halogens decreases down the group. Fluorine is diatomic molecule even in solid state. Production or synthesis of fluorine is a major challenge because it reacts with practically any material known. It passivates surface of stainless steel or nickel, so the vessel can be made of these metals. Alternatively, as many parts as it is possible are made of Teflon, which is infinitive chain of already fluorinated carbon atoms, so no further reaction with fluorine is possible. The electrolysis is done from HFKF electrolyte, and the result is hydrogen gas and fluorine gas. It is very difficult to store and operate with fluorine, so it's seldom used in practice. Hydrofluoric acid, on the other hand, is well known. It is a liquid boiling very close to room temperature, 20 degrees Celsius. All other hydrogen chloride, hydrogen bromide, and hydrogen iodide are gases at room temperature and well below. The reason of such high boiling point is the same as for water molecule, very strong hydrogen bonds. HF makes chains FHF with relatively short distance between fluorine and hydrogen of another molecule. HF dissociates in water, but in presence of extra HF molecule, it makes complex anion HF2- with symmetric arrangement of two fluoride ions around one hydrogen ion. Distance HF around 1.14 angstrom, like this. This is very stable compound. You can crystallize potassium sulfate, for example. Hydrogen fluoride easily reacts with many compounds, reacts with many metals, practically with all metals in presence of oxidizer. It reacts with glass and quartz, making or silicon tetrafluoride gas or silicon fluoric acid, H2SiF6. Some of fluorides have low solubility, least soluble is calcium fluoride, famous mineral fluoride. Strontium, magnesium, lead, barium are better soluble. Lanthanum or lanthanoids fluorides are also low soluble. You can enjoy two beautiful YouTube videos showing reactions of fluorine. It's a very exotic and difficult experiment to do.